Okay, so now we're going to be talking about the definition of a derivative. We already kind of know that a derivative is a way to find the slope at a specific point, or the derivative is the equation to find the slope at any point on a function. But why does this happen? In the past years, whenever we wanted to find a slope, we've always used the equation y2 minus y1 over x2 minus x1, just meaning like rise over run. So the change in y and the change in x, or the change in y and the change in x, equals your slope. Now another way to say this would just be your slope is equal to your f of a plus h, where h is just any difference in x from a, minus your f of a, which is just your starting y function, all over your a plus h, where again h is just any increase in x, and a is just minus a, which is just your starting point. Now you might notice that a plus h minus a cancels out here, so you just slope is equal to f of a plus h minus f of a over h. This is basically the same thing as that. It's just a way to find your slope. And what this finds is the secant line, the slope of the secant line between 2 points. So between here and here, you just find the straight line here. So this line actually curves a little bit, but it wouldn't account for that. It's just going to be the straight line between these 2 points. Now, that's not exactly what we want for a derivative, because a derivative is the slope at a specific point. It's the tangent line of the equation. And for us to find that, if you think about it, we have these 2 points using this equation. We can find the slope here. But how about we make h smaller and just make the point here, and then you can find the secant line between these 2 points. Or you can make h even smaller and put it here, and you get the secant line here. And if you just get closer and closer, you can get pretty close to the actual tangent line coming off if you make h small enough. So, to find the actual tangent line, what we do is we take the equation we just established, f of a plus h minus f of a all over h, and we find the limit of that equation as h approaches 0. So as h, the difference, gets as small as possible. And when it gets that small, we can basically say that we've got just 1 point, even though there is technically a super small difference between the two. You can just say that that is the line, the tangent line. So that is our equation. F prime of x is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h, where h is just the difference, any difference from a. So if we want to use this in some example, we can try to find the derivative of the function x squared plus 9x when a equals 2. So if we take the equation we just learned, we have f of a plus h minus f of a over h. So what we need to do is find f of a and f of a plus h. H itself is just going to be, we're going to leave it for now because eventually we're going to have to find the limit of it. So first we can start with f of a, which is easy. You just plug in a into the function. So you get a squared plus 9 times a. So you get 2 squared plus 9 times 2, 4 plus 18, which equals 22. So that's easy. And then we try to find f of a plus h. Since we're leaving h as it is for now, you have to actually plug in 2 plus h into your function. So you get 2 plus h squared plus 9 times 2 plus h. And if you solve this, or not solve it, if you expand it, put it together, you end up getting that f of 2 plus h equals to h squared plus 13h plus 22. So now that we have f of a and f of a plus h, you can put them together in the equation, and you get f of a plus h minus f of a. So h squared plus 13h plus 22 minus 22, and you put it all over h, and you're still finding the limit as h approaches 0. So you might notice that the 22's cancel out here, so you just get h squared plus 13h all over h. And then the h's actually cancel out, so you get the limit as h approaches 0 of h plus 13. And then finally, Since you're finding it as h approaches 0, when h is 0, it's gone and you just get 13. So that'd be your final answer. So the derivative of f of x equals x squared plus 9x at a equals 2, the slope would be 13. The derivative would be equal to 13.